All right. So, at the top of this, we have I can statements. I am a firm believer in positive affirmations and helping you to believe that you can actually do something. So we have, I can represent intervals using interval notation. Yes, you can. Yes, we can. It doesn't have to be difficult. It may be challenging, but we always overcome challenges. Okay? We also have, I can represent intervals using set builder notation. So, if you ever get stuck and you get frustrated, just say what you can do. Okay? Even if it doesn't look like it right now. All right? So, let's begin. A collection of objects is called a set. A set. We use braces to represent a set by listing its members or elements. So, pieces or parts of a set, we call them members or elements of that set. Okay? If all of the members of set A are also members of a set B, then set A is a subset. Subset of set B. If set A equals A and B, and set B equals A, B, C, D, then set A is a subset of set B. So we see that set A has the letters A and B inside of that group, right?
Yeah.
Okay? We see that set B has A, B, C, D inside of that group, correct? So because set A have two of the same elements from set B, that means that it's a subset. It's just a smaller group. Everyone good? All right. So now let's get into our numbers. So the set of natural numbers, they start at 1. It's positive numbers starting at 1. That's the set of natural numbers. It is a subset of the set of real numbers. So we're going to do this diagram, this box down here. We're going to do this diagram, okay? So this whole entire box, I don't think I have another, let me get a So, this entire box, I'm going to outline it. It's not the best. That entire box is going to represent real numbers. If you have highlighters, you can get them out. For this box, we're going to highlight or color in each section. I have highlighters here. I have some colored pencils here. Different color pens. You can do that. You can use that as well. We're going to highlight so we can visually see sets and subsets. If you someone doesn't have some, please share. All right, so this big entire box represents real numbers. Sometimes we will see a notation, a symbol for real numbers, and it will look like an R with a double line. Sometimes you will see that. When we write it, we usually write it with a double line, or you will see it looks like a two R's kind of stacked on side of each other if you look inside of a book. But it looks like this. Think double. If I see a double line on an R, it's talking about real numbers. Okay? Next, I have this section over here. that section there. Irrational numbers. Irrational numbers. On the other side, I'm only going to highlight just this outside part, but think of this whole entire side though, okay? Okay, so this entire box represents real numbers. Okay? I'm then going to split my box. So this line here, I'm splitting my box. Over here is irrational numbers. On this side are rational numbers. Rational numbers. And the symbol for rational numbers looks like a Q with a double line. Okay, so real numbers, I split it into rational numbers on one side, irrational numbers on the other side.
So there's no symbol for irrational numbers?
You said what?
There's no symbol for irrational numbers?
No. Really don't use it as often. Everybody good? Okay. Inside my box of rational numbers, the next set I will find are integers. So integers, I-N-T-E-G-E-R-S. The symbol that you will see here will look like a double Z. Okay. Looks like a double Z, double Z. All right, inside my box of integers, I have whole numbers. So integers, they include the negative numbers and positive numbers, including 0. Whole numbers, they start with 0, start at 0, and they're positive. So 0, 1, 2, 3, 4, and so on and so forth. So whole numbers. The symbol that you will see for whole numbers is a double W. So W with a double line. And then inside my group, my subset of whole numbers, I have the natural numbers. And the natural numbers, like I said previously, they start with 1 and they are all positive. And this symbol is a double N.
So the only difference between whole numbers and natural numbers is that whole numbers include 0?
Yep. Excellent job. Is everyone good with the set of real numbers? So when we begin to talk about interval notation, domain, and range, a lot of times you will see that, so if we drew a line, we would have it going from one direction to the other, and all possibilities on my line for my x values, which will be my domain, would be all real numbers because it's going from left to right. And it's going to keep going. Okay? Does that make sense? So you will see all real numbers often, often, often. All right, let's move forward. Next, we're going to talk interval notation. So we have bounded intervals on the real number line. So we let A and B be 2 real numbers. So any number, okay, within the set of real numbers, such that A is less than B. Then A and B are the endpoints of 4 different bounded intervals on the real number line. Four different bounded intervals on the number line. So, we could have a bracket, which our bracket, we look like this. We'll have an opening bracket and a closing bracket. Or a closed circle. We'll have a bracket or a closed circle that indicates that the endpoint is included in the interval. So if I want a list of numbers, let's say 1, 2, 3, 4. 1 is included in that. 4 is included in that. 2, 3. Okay? Makes sense? If I was to place that on a number line, you can see that. This is just an example. This is my number line. I'm going to place 1 there. I'm going to place 4 there. I want all the numbers between 1 and 4, and I want 1 and 4 included in that interval. Okay? So that means I'm going to have a closed circle at 1 and 4, and that means that those 2 are included in that interval, in that group of numbers that I want, and then I'm just going to shade in between the 2. So closed circles and then shade. Okay? Another thing that I can have, I'm just going to kind of write over it with my red, are brackets. So I can have brackets here and there. That still means the same thing, that I want those endpoints included in my interval. Everyone good? Sweet. All right. So then I can have a parenthesis. A parenthesis. Multiple is parentheses. So I can have a parenthesis. The plural of the parentheses, of course, they look like that. Or an open circle. An open circle that indicates that those two endpoints are not included in that interval. So let's use 1 through 4 again. Using 1 through 4 again. I have 1, I have 4. Those two endpoints are not included in my interval. So I'm going to have an open circle. And then I'm just going to shade. So pretty much what I want is in between those two, not including those two endpoints. Everyone locked in? All right. So I could also have, remember, parentheses. Parentheses here, parentheses here. So you may see parentheses on a number line. Most times on the number line, though, you will either have a closed circle or the open circles. Okay? All right. Let's move forward. We're going to fill in this chart. We're going to have the inequality. We're going to have what it looks like in interval notation, and then we're going to graph it on the number line. Now I'm going to use the letters A and B just to represent any number that we may have. I'm going to use A and B, all right? And in this case, A is less than B. So A is going to be listed first and then B. Everyone good? All right. So, first things first. All right. Use a different color. So let's say in interval notation, I have an open bracket A, B, and then closed bracket. That means I'm going to use X to represent my values that I need in between those. Okay? That means going over here to the inequality, that A is less than or equal to X, which is less than or equal to B.
So when you see interval notation, is it always from smallest to greatest?
Yes, always. Always, always. So just to reiterate what he asked, whenever we are writing an interval notation, it is always left to right, smallest to greatest. So let's use the number line. I have A here and I have B here. Notice that on the number line, I do not have to list all the numbers in between. I'm just going to put my endpoints on the number line, and then I'm going to shade either between or whatever that I need, okay? That'll save you some time, save me some time whenever we are doing interval notation or graphing it, okay? So I know that because I have, notice the symbols that we have for the inequality. We have less than or equal to. So if they have a line underneath on that inequality, I'm going to have brackets. Okay? So both of these have lines underneath on that inequality. I have brackets on both of my endpoints. So that means that both of my endpoints are included in my interval. So I'm going to have closed circles on my graph. Closed circles. Closed circle here. Closed circle here. And then I'm going to shade. You can use a highlighter to shade the portion that you need. You can do the scribbles like I did before. That's perfectly fine as long as I see it. Everyone good? Okay. Next, let's say I have an interval notation for open parenthesis A, B, close parenthesis. So that means for my inequality, A is less than X, less than B. So all of my X values are in between A and B. And A and B are not included. A and B are not included. So when I graph this on my number line, here's my A, here's my B. Because they are not included, because I see the parentheses here, and because they don't have the equal to sign underneath that inequality, those endpoints are not included. So I'm going to have an open circle. Open circle on my number line, on my graph. And I'm going to highlight in between. In between those two values are all of my possibilities for my X. Does that make sense? Okay. Bless you. All right. Another interval. We have an open bracket, A, comma, B, and then we have an open parenthesis. We have a parenthesis, a closed parenthesis. Open bracket, A, B, closed parentheses. Bless you. So what would my inequality look like if I have two separate groupings? So the open bracket means that I have A less than or equal to X less than B. So one of my inequalities has a line underneath. The other one does not. Remember, order matters. Order matters. Okay? So when I graph this on the number line, I have A, I have B. Which one is going to have the open circle? Excellent job. B is going to have the open circle. So that means A is going to have what? Excellent job. And then I'm going to highlight in between. Okay. So then another interval. We have these four possibilities for these intervals. We have four possibilities here. Whenever we just have the numbers. When we're given two numbers, specific numbers, we'll always have four options. We'll have two closed ends, two open, closed and an open. So the last one is an open, closed. Yep. So we have open parentheses A, B, then a closed bracket. So that means my inequality is I have A less than X less than or equal to B. Here's my A. Here's my B. Which one is going to have the open circle? Excellent job. That means B is going to have, yes. Then I'm going to highlight in between. So let's talk about these last two real quick. For the first one, we had both closed circles. We had the brackets on both ends. That means both of those endpoints are included in the interval, right? Okay, for the second one here, we had two parentheses. That means we had two open circles. That means that my endpoints are not included, right? So what can you tell me about my endpoints for this one? What can you tell me about my endpoints for this one?
A is included, B is not.
Yes, A is included, B is not included. Okay, what about this one?
B is included, A is.
Yep. B is included, A is not. So remember, order matters. Remember that each of the symbols represents something. Okay? All right, moving along. So any bounded interval has a finite length, meaning we can count it. We can count each of those numbers in between those two endpoints. Okay? An interval that does not have a finite length is called unbounded. Or infinite. If it is infinite, that means we can't count it. Does that make sense? So finite, we can count it. We know it's a bounded interval. Infinite means that it's unbounded. We can't count it. All right? So the symbols we have positive infinity, positive infinity. You could see it with the plus, but we don't have to write the plus. It's just a sideways 8. Positive infinity is a sideways 8. If you need to do two small circles connected beside each other, that's perfectly fine. Okay? So we have positive infinity and we have negative infinity. The negative infinity must have the minus sign in front of it. Okay? It must have it. It must have it. So, positive infinity and negative infinity are used to represent the unboundedness of intervals. So, for instance, let's say we have bracket 7 to positive infinity. I'm going to graph this. I'm going to show you what it looks like. Seven to positive infinity. If I am using a number line, my endpoint is 7. So I have 7 here. 7 is included. So it's going to have a closed circle. And then I'm going to highlight everything to the right. And then I draw the big arrow. That means that it's going to keep going. That means it's going to keep going. It's unbounded. So whenever you see infinity or negative infinity, it will always have a parenthesis. Okay? Because it's unbounded. We can't count it. We can count a finite endpoint. We can count 7. We know what 7 is. We don't know what infinity or negative infinity is. Does that make sense? Questions so far? Okay, let's look at graphing the negative infinity to 7. So I have 7. My 7 is included or not included? Included, yes. We're looking at this one here. So it's included, so it gets a closed circle. Am I shading to the left or the right? Yep. Does infinity get a bracket? You are correct. It does not get a bracket. Good job. Okay, everyone good? Going to the next page. So we're going to do the same thing as before, but our table is going to be with unbounded intervals. All right. So first, the interval notation. Bracket A, positive infinity. So my inequality would look like my x values are greater than or equal to A. So all of my x values are bigger than A, but my interval also includes A. All right? So I'm writing A somewhere on my number line, doesn't matter where. A does get a closed circle because it is what? Yes. And then I'm just going to highlight the rest of my graph, my number line, and put an arrow at the end. Okay? Next, I have open parenthesis, A, comma, positive infinity, close parenthesis. So my inequality, all of my x values are greater than A, and A is not included. So I'm placing A on my number line. A is not included, so it gets what? Yes, it does. Excellent job. Open circle, then I'm going to highlight the rest of my number line with an arrow at the end. All right, next, I have open parentheses, negative infinity, comma B, closed bracket. So this one means that all of my x values are less than or equal to B. So I'm placing B on my number line. Is B included or not? It is included. So it gets a closed circle. And I am shading to the left. And add an arrow. Next, I have x less than B. So open parentheses, negative infinity, comma B, close parentheses. Placing B on my number line. Open or close circle? Open, open, open circle. So open, and then I'm shading to the left, the arrow at the end. I'm going to draw a line underneath here because we have one more thing to represent. So what if I have this awesome one, open parentheses, negative infinity, positive infinity. Am I ever going to see any brackets here?
No.
That is absolutely correct. So whenever I see negative infinity to positive infinity, that means all my possibilities for x are all real numbers. All real numbers. So if I was to do this on my number line, I sure would. I would shade the whole thing. Arrows on both ends, because I'm going as far negative as I possibly can, and I'm going as far positive as I possibly can. Questions on interval notations, the inequalities, graphing those? Questions? Okay. Let's do these two examples down here. All right, so let's write each interval in interval notation. Zoom in a little bit. All right, so I have -2 less than or equal to x, which is less than or equal to 3. So I have both less than or equal to. So that means that, are they closed or open? Absolutely. So when I write this in interval notation, I'm going to have -2, +3. Both ends will get brackets. Okay? All right, so B. This is x greater than -1. Is this open or closed? So this is telling me that all of my x values are greater than -1. Okay? So my first endpoint is going to be that -1. So open parentheses, -1. And since they're all greater than -1, it's going to keep getting positive and more positive and more positive. What is this over here? Yep, positive infinity. And what does it get? Yes. Excellent job. All right. Stop here for today.